Let's try a proof together that involves parallel lines and transversals. We have some given information here and a diagram to go along with this proof. Alright, so here are our two columns, and let's take a look at our given information. So we're told that lines G and H are parallel, which are these two lines over here. The other thing that we're given is that angle 1 and angle 4 are supplementary angles, which are these two angle measures. Let's see if we can figure out why they gave us these specific bits of information to prove that line P is going to be parallel to line R. Alright, so for statement 1, let's say that angle 1 and angle 4 are supplementary, and that was given. Now, why did they tell us that, or what can we tell from that given information? From that, we know that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. We can go ahead and justify this by using the definition of supplementary angles, where if we know that two angles are supplementary, then their sum is going to be 180 degrees. We used one of the given bits of information. Now let's go ahead and use the other one where they tell us that line G is parallel to line H. This is given. So what can we tell if we know these two lines are parallel? If we know these two lines are parallel, and we can see that line P is a transversal to these two parallel lines of G and H, then this angle of angle 1 and angle 2 must be congruent by the alternate interior angles theorem. So let's go ahead and say that angle 1 is congruent to angle 2. And this is by the alternate interior angles theorem. Now if we know angle 1 and angle 2 are congruent, then we can say that the measure of angle 1 is equal to the measure of angle 2 by the congruence property of equality. So if we know these two angles are congruent to each other, then we know their angle measures must be equal to each other. Alright, so let's start putting some pieces together here. If we know that the measure of angle 1 is the same thing as the measure of angle 2, they're equal to each other, and we know that measure of angle 1 plus measure of angle 4 is equal to 180 degrees, we can go ahead and swap out this measure of angle 1, which is in both of these equations, and make a substitution and say we know that the measure of angle 2 is going to take the place of the measure of angle 1, because we somehow need to link something on line P to something on line R to prove that they are parallel. So we see measure of angle 1 here, which we see again over here, and it has the same measure of angle 2. So making a substitution, we can say that the measure of angle 2 plus the measure of angle 4 is going to equal 180 degrees. And we know this by the substitution property of equality. So we now know that the measure of angle 2 plus the measure of angle 4 is equal to 180 degrees. And if we notice here, angle 2 and angle 4 are going to be between lines P and R. So if we look at lines P and R, and focus in on H being the transversal, we can see that angle 2 and angle 4 are consecutive interior angles. Now if we know that angle 2 and angle 4 add up to 180 degrees, we should be able to say that they are supplementary. We can say this by the definition of supplementary angles. Now notice that angle 2 and angle 4 are consecutive interior angles, and if they are supplementary, then lines P and R must be parallel. So for our eighth and final statement, we're going to say that line P is going to be parallel to line R, and we can say this by the converse of the consecutive interior angles theorem. Now hopefully this makes sense, because if we were given the fact that this line P and line R were parallel to each other, then we could go ahead and use the consecutive interior angles theorem and say that if we know that this is a transversal going through these two parallel lines, and we can go ahead and say that these two consecutive interior angles are going to be supplementary. However, in our case, we were able to figure out that angle 2 and angle 4 were supplementary angles, so we went ahead and used the converse of the consecutive interior angles theorem and proved that this line P is indeed parallel to line R. Alright, so that just about wraps up this proof. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.